Today we're going to go over the prototype pattern. This pattern is useful if we had some existing objects and we needed to keep cloning them instead of creating new ones from scratch. The best way to put this into example is thinking about if you had a web navigation menu, that you had different objects that were items within the menu, such as a home button, an about button, a services button, a blog button, but they all had shared the same structure. They all have a label, an icon, a link, and a visibility flag. If we think about that item to item, maybe only a few fields may change, we can think about not having to completely individually create each and every single one of those items, but since there is similarities between those items, we can think about using this pattern to, instead of creating new individual items from scratch, we can just clone the items and just modify only certain fields instead of having to continuously make new ones. So we can create one object, clone it, and then we can override what's different. Without the prototype pattern, we have two problems. First, we see that there's a repetitive constructor. Every menu item will need the same 4 arguments and the same 4 positions. And that's a little bit more cognitive overhead, and it becomes a maintenance hazard if the construction signature ever changes. The second one we have is expensive initialization. In a real system, if we're building an object, might involve having something like a network request or a database lookup, or we're reading from a config file. If every object in your set needs that full initialization, then we have that huge cost every time, even when 90% of the state is identical across all of them. If we think about it, the prototype pattern says we pay only for the construction cost once, and then we make that object or prototype, and then from there we will clone for every subsequent object. In the Gang of 4, the definition that they provide is it specifies the kinds of objects to create using a prototypical instance and creates new objects by copying this prototype. In practice, you designate one fully configured object as the template, and that we call that the prototype. Anytime you need a new object of that type, we can just call the clone method, like there's something called prototype clone, instead of creating a new instance of that object. The clone starts with all of the prototype values. You just override just the fields that you need to change. The pattern lives in the creational category because its primary purpose is controlling object creation. Specifically, it decouples the client from the constructor. The client doesn't need to know the class name, the full argument list, or the initialization logic. It just calls the clone method. Here we have the structure diagram that we're going to use in our demo. The structure is very limited. It just has one class with the clone method. In the classical Gang of 4, there's usually an abstract prototype interface that declares the clone method, and one of the or more concrete prototypes will implement it. In Typescript, there's just a single concrete class. You can just often skip that abstract layer. And in this repo's implementation, the menu item is both the prototype contract and the concrete implementation. There's no separate interface. The clone method returns a new menu item that's pre-populated with the current instant value. The client creates one prototype instance and then calls that prototype clone method whenever it needs another object. Here are the participants in the implementation. So the first one is the menu item. This is the prototype. It holds 4 properties: the label for the display text, icon for the emoji, and is visible whether or not the item renders at all. It implements the clone method by constructing a new menu item from its own current values. A proto is a concrete prototype instance. It's created once with something like the new menu item home with these arguments. This is the master template the object with the most common defaults. And then here we have item 1, item 2 are the clones. Item 1 gets the label about, icon, link. It has its own button, the about button. Item 2 is the services button, and they both inherit is visible true from the prototype without a single line of code to set it explicitly. So here we have no abstract interface, there's no factory class, there's no registry, it's just a prototype, a clone method, and a client. Here's the full menu item class. There's 4 properties that are declared at the top. There's a constructor that assigns them all. At the bottom, there's a clone method. It's a single method that does all of the prototype pattern's work. And if we look at it, the menu item doesn't extend any abstract base class. It doesn't implement a named prototype interface. In Typescript, you automatically get that prototype pattern as long as the clone method exists and returns the right type. So this is kind of like duck typing at work. If we look at the clone method in isolation, we see again it creates that menu item from the pre-populated instance variables that we have in the class. This is a shallow copy using the constructor. It reads every property of this and passes it on into a fresh instance. So for menu item, shallow copy is correct. All 4 properties are primitives, strings, like strings and Boolean. There's no nested objects. There's no arrays, no shared references to worry about. The clone is fully independent of the prototype from the moment it's created. In a more complex class, if we had like a menu item that holds a nested permissions object, in this case, you'd have to decide, should the clone deep copy that nested object or should it just share that reference? And that's the classic prototype trade-off. For simple objects like this one, you never have to face it. Now the client, this is the index TypeScript that kind of connects everything together. This is the cleanest illustration of the pattern at work. We look at the top, we have one constructor call, that's the prototype. Then we have the first item, we have the clone, and then from the clone, we're setting the label, icon, link, and the is visible property is never mentioned because it doesn't need to change, it's already inherited. And then we do the same thing for item 2, we just clone it, and then we override those 3 properties. For 15 menu items with mostly shared state, this just prevents you from repeating that is visible true field 15 times. And when the default for the is visible changes, you change it in one place, the prototype. And every future clone picks up that new value automatically. Here we have our demo. If we think about the prototype pattern, we are just simply basically just cloning from one object or class. We call this the prototype. Our main class and item that we're constructing from is just the single menu item. And from there, we can create these 2 specific items. This first menu item is the about page. The second menu item is a service page. And this is what they look like. They do look drastically different, but the only real big differences they have are the about, their label, the icon, and each of them linked to a different HTML page. If we look at the class that we have here, first we're creating that prototype, which is here. And all this does is just is the object that we want to make sure we're copying over. And again, since we're copying this over, we're cloning, we don't have to even modify this part. Here, all of these are going to have the is visible. And the clone will return the new menu object with everything that's the same label, the icon, the link. And later from here, all we're going to do is just override those specific values. And once we override those values, then from here we can create these buttons and items on our navigation bar without having to create a totally new menu item, which in theory we are doing that, but the idea is more specifically If we were calling a config file, if we're doing a database lookup, if we're doing anything where in this class it would be a little bit more exhausting or use more resources, we would be able to do this one time, and from that one time we'd be able to just populate it here into another menu item without technically having to create a completely new one and go through the process of instantiating those values on their own. There are other benefits, but I guess the other big benefit too to doing these clones is thinking about, is there some values that we will propagate down to these other menu items? Let's say, for example, there's only a few fields you want to override. In that case, having the clones is much easier to manage, especially if it's a dynamic object that you just want to clone, because then you don't have to keep track and take care of, hey, I need this value to propagate to all of these objects. You could just have the prototype have those specific base values, and then we can just propagate them to all the other clones. When we want to use the prototype pattern, we want to think about first when we have objects, many objects share most of their state. If we think about the menu that we had, it's just a family of similar objects with one or two fields, differ per instance. So if we had the prototype pattern, it just eliminates this constant repetition. The second one we think about is when object construction is expensive. If we have the initialization and involves input-output, computation, or external calls, we can just pay that cost once for the prototype, and then we can clone cheaply from there. The third we want to think about if we want to avoid subclassing. So without a prototype, like in the example we had before, we might have to create this home menu item, about menu item, the service menu item. We're going to have to create this specific menu item for every single one that we have. Instead of doing that, we could just use one class and then we just override the specific fields that we want. And lastly, when we think about a default class or field should be centralized. That way, if we want to modify all of the subclasses or all of the different clones, we can just change that prototype once, and then all of the clones that can pick up the new default automatically. In that case, we wouldn't have to find and replace all of the different multiple constructor calls. We don't want to use the prototype pattern if the construction is trivial. If we think about creating these new classes, it's already fast and the arguments don't repeat, then that clone indirection just adds more complexity and it's not very helpful for a case. If the shallow copy semantics are wrong, if the object holds nested references like arrays, nested objects, and cloning copies the reference, not the object, then we can see that two independent clones can share the same nested data, which can lead into some aliasing bugs. And that means that the objects themselves start to continue to copy the arrays and nested objects within each other, and so later it becomes more complicated because you have maybe two clones or 3 or 4 quote-unquote new objects from clones, but inside internally they might all reference the same nested reference, which you can already imagine that creates some complexity and can cause some future bugs with that kind of issue. And the third, when objects must always start from a known clean slate. If every instance should begin with an empty state rather than inheriting defaults, then the prototype doesn't work. If we're not having to have some kind of default in the first place. We also want to think about when another creational pattern fits better. If construction varies across the structural dimension, like subclasses and configurations, we can think about the factory method or abstract method. That might be the right tool. If construction is a multi-step process with many optional parts, then the builder is probably a cleaner pattern to use and to follow. We have 3 real-world analogies to help explain and to make this pattern stick. The first one, we think about cell division. Every cell in your body is a clone of the original zygote. The DNA is the prototype. When a cell specializes, if it becomes a liver cell, a neuron, a skin cell, it just overrides the specific gene expression, so the rest of the genome is inherited. Second, if we think about the document templates, a law firm maintains a standard contract with all the boilerplate filled in. For each new client engagement, a lawyer will just clone the template and fill in only the client-specific fields like the name, date, scope, fee, and everything else will be inherited from the master template. And we also want to think about 3D printing. You design a model file once, we have the prototype, and each print run copies it. It scales it. It has a color, material, infill, percentage. Those are the post-clone overrides. The base model that we had is the prototype. We have two patterns that are easy to confuse with the prototype pattern. So the first one we have is the factory method pattern. The factory method uses a method to instantiate objects. It is often choosing among subclasses based on some condition. The client calls the factory and gets back a concrete object, but it doesn't control which class gets instantiated. Prototype doesn't subclass, it copies. There's no factory hierarchy, no abstract creator. There's just the clone method on the object itself. And then we also think about the prototype method versus prototype pattern versus the builder pattern. So the builder assembles complex objects step by step using a fluent interface. You call set X, set Y, and then build method. You reach for the builder when an object has many optional parameters in a specific assembly order. The prototype is simpler. You start from a known state, you override a few things. There's no director class, no fluent chaining. The rule of thumb is if you have good defaults with small deltas, then you want to use the prototype. If it's a polymorphic creation across a class hierarchy, we want to do the factory method. And if it's a multi-step construction with many moving parts, we want to use the builder pattern. Here we have three key takeaways for the prototype pattern. The first one is it creates once, it clones many. So a single construction call sets up the prototype. Every subsequent object is a cheap copy of that foundation. The second one is we override only what differs. Inherited properties create zero code. The prototype will handle the defaults. And the third one is the clone method is the entire API. There's no factory hierarchy, there's no abstract creator, there's no registry. There's just a method that returns a copy of the current object. The prototype pattern is deceptively simple, a single method on a single class, but it solves a real problem, eliminating repetitive object creation and scales gracefully when you have dozens of similar objects instead of two. And this is the video I have for the prototype pattern. You can go to the repo linked in the description. The pattern has a standalone browser demo, so you can run it, or you can access the website from the GitHub pages live. We have the other patterns in this repo, in the creational repo. I already have videos on the builder, abstract factory, and the factory method. You can go into the next videos if you want to learn more about the builder for multi-step assembly or the abstract factory for coordinated families. If you really like this video, if you can like, comment, subscribe, it would help me just get more motivated to create more videos. And just let me know if it's been helpful, but I appreciate everything and thank you for watching. All right, bye.